I'm going to give you a brief demonstration here of an illustration of the famous butterfly effect, which is how small differences at the beginning can result in very large differences at the end when you're dealing with complex systems. What we have here are two pendula. They're called double pendula because they can pivot not only at the top but in the middle. And I'm going to illustrate how you can get simple behavior from this and also very complicated behavior. If I start these two pendula, they're pretty much identical pendula. If I start them from basically the same place, as you might expect, they do basically the same thing. If I want to predict what they're going to do in the future based on where I started them, you can tell they're both on the right, left, right, left, right, left. They're both doing about the same thing. However, if I start them out up here, again, I'm starting them from basically the same place, but when I let go, you can see that very quickly they're now doing completely different things. So if I wanted to try and predict what one of these pendula would do based on where I started it, it would be very difficult because even if you start identical pendula from very similar starting points, within just a few seconds they're doing radically different things. So the butterfly represents the slight difference in where they started, and the hurricane represents the fact that they're doing very different things later on. So it's not that the butterfly causes the hurricane, it's that the butterfly and the hurricane represent small differences at the beginning and big differences at the end.